The following the following grammar is option A LL1, option B ambiguous, option C operator grammar, option D both B and C, that is both ambiguous and operator grammar. So if we see the given grammar, it is both left recursive and right recursive. Whenever a grammar is both left and right recursive, that grammar is ambiguous, and it is also an operator grammar. Why? Because in operator grammar there is no, there will not be any epsilon rules, and there will not be any two adjacent non-terminals on RHS of any production. So here the grammar is both ambiguous and operator grammar. Let me write the definition for operator grammar. Operator grammar: a grammar in which all the productions shouldn't contain epsilon rules or two adjacent non-terminals on RHS part. So if all the productions, if the RHS part of every production doesn't contain epsilon rules and two adjacent non-terminals, then that grammar is said to be operator grammar. So this is operator grammar, and this grammar is both right and left recursive. If the grammar is both right and left recursive, then it is ambiguous grammar. If the grammar is both right and left recursive, then that grammar is ambiguous. So here option D is the correct answer.
If the memory access time is 100 nanoseconds, the swap fault overhead is 25 milliseconds, and page fault rate is 0.001. Find the effective access time. A 25 nanoseconds, B 25 milliseconds, C 25 microseconds, D 23 microseconds. So here we need to find out the effective access time. Okay, there is one formula in a paging, that is effective access time is 1 minus P into memory access time plus P into page fault service time. That means swapping. When the fault is occurred, we need to swap the faulted page from backing store to main memory. So it is 1 minus P is given as 0.001 to memory access time is 100 nanoseconds plus 0.001 into page fault service time is 25 milliseconds. 25 milliseconds means we have to convert it to nanoseconds. So this will be 25 into 10 power 6 nanoseconds. 1 millisecond is 10 power 6 nanoseconds. Okay, so now here this will be all are in nanoseconds now. Okay, so finally we will get around 25 into divided by 10 power minus 3, something like this. Okay, this will be around 25 microseconds. The result of this evaluation will be 25 microseconds. Option C is right option. Private network is A. Now that is, there are some points given. A secure network, an unsecure network. Secure network, if a challenge is thrown from the secured system, it can never be a secure as it bypasses the firewall. So basically virtual private networks is for it is a secure network. It is not insecure, it is a secure network. So these three are wrong, because secure networks, if the challenge is thrown, even if the challenge is not there, it is a secure. It can never be secure as it bypasses the firewall. So it is wrong. So option C is right option. The congestion in any link can be controlled by 2 points are given: buffering of packets, traffic shaping. A 1 only, B 2 only, C both 1 and 2, neither one nor 2. So here we need to have the congestion control. Normally the congestion control can be done either by means of buffering the packets and traffic shaping both. When you shape the traffic, we can control the congestion. When you buffer the packets, you can control the congestion. C is right answer.
The number of candidate keys in the following relation are A, B, C, D, E with the following set of functional dependencies. In this question, a set of functional dependencies for the table with 5 attributes is given, and we have to find the number of candidate keys for the given relation. So if we see the functional dependencies and find A closure, will be getting A, B, C, D. From A we can get we can derive B. From B we can derive C. From C we can derive D. From D we can derive E. From E we can derive A. So A closure will be deriving all the attributes of the table. So we can say A is a candidate key. If we find B closure also, we'll be getting A, B, C, D, E. So even B can derive all the attributes of the table. So we can say that B is also a candidate key. So if we find C closure also, from C we can get D. From D we can get E. From E we can get A. From A we can get B. So even C is also a candidate key. If we find D closure, from D we can get E. From E we can get A. From A we can derive B. From B we can derive C. So even D is also a candidate key. If we find E closure, from E we can derive A. From A we can derive B. From B we can derive C. From C D, and from D E. So even E closure is also deriving all the attributes. So E is also a candidate key. So here we have total 5 candidate keys. So correct option is option D. Each subject may be taught by several teachers, and a teacher may teach several subjects. Can be represented by which of the following ER diagrams? So here in this question a scenario is given, and we have to represent the given scenario in terms of ER diagrams. Here the given statement is each subject may be taught by several teachers, and a teacher may teach several subjects. So here we can take subject and teacher as entity sets, and we can represent the relation by taught, and that if we see the statement that relation should be many to many. Why? Because here it is given that a subject can be taught by several teachers, and a teacher can teach several subjects. That means the relation should be many to many. And here the participation of both the entity sets, subject and teacher, should be partial. Why? They are not total. Why? Because if you see the statement, each subject may be taught by several teachers. That means there may be a subject which may not be taught by any teacher. If it is total, then statement should be like this: each subject may be taught by at least one teacher, or else each subject may be taught by one or more teachers. Then that subject entity should be should part should participate total. Then that then the participation of subject entity set to subject should be total. If the statement is each subject may be taught by one or more teachers, or by at least one teacher, then it should be, then the participation should be total. But here it is, statement is like this: each statement may be taught by several teachers. So here the participation of subject entity set subject is partial, and it is represented by single line. Here it is single line. If the participation is total, then it should be represented by double line like this. So here it should be partial, and the participation of entity set teacher is also a partial. Why? Because here the statement is teacher may teach several subjects. That means a teacher may teach or may not teach subject. So it is partial. So here it should be single line, not double line. If it is total, then statement should be like this: teacher may teach one or more subjects or at least one subject. Then the participation would be total. So here it is partial. So here correct option is option C.